Okay, equilibrium question. We're given some details about a reaction between ethanoic acid and propan-1-ol. These will, of course, make propyl ethanoate. We're told that after the mixture was heated, it was then cooled rapidly and titrated with 1 molar sodium hydroxide solution. We know how many moles of concentrated sulfuric acid were added, so we know how much acid needs to be neutralized before we can detect any of the acid from the ethanoic acid mixture with the propan-1-ol. Okay, let's just take the question one bit at a time. Calculate the volume of sodium hydroxide solution that would have been needed if only 0.001 moles of concentrated sulfuric acid had been in the flask. So what we need to do is we need to put down the equation for the reaction. NaOH is going to react with H2SO4. Now, we should be able to see here that there are 2 hydrogen ions from the sulfuric acid. Whoa! 2 hydrogen ions from the sulfuric acid, which means that we would be expecting there to be 2 sodium hydroxides needed. And in fact, this is the case. The equation for the reaction gives us Na2SO4 plus 2H2O. Let me put these. I'm going to format these. Now, this basically gives us the ratio of sulfuric acid to sodium hydroxide. You see, it's 2 sodium hydroxide moles for 1 sulfuric acid mole. So if we start, if we have 0.001 moles of sulfuric acid, 0.001 mole of sulfuric acid is equivalent to, I'll put equals here, I'll do sulfuric acid, will be equivalent to twice as many moles, 0.002 moles of sodium hydroxide. So we need to know the molarity of the sodium hydroxide, right? The molarity. So we want the volume. So the volume, well, first of all, just remember that moles equals molarity times volume. Therefore, the volume equals moles over molarity, which in this case is equal to, well, the number of moles is 0.002, and the molarity, we're told, is 1. So that equals 0.002 litres or 2 centimetres cubed, 2 millilitres. I wanted to format this in a nice colour. There we go. Let's take it into blue so we can see it. Right? Nice blue colour. Calculate the volume of sodium hydroxide solution that must have been needed to react with the ethanoic acid remaining. Right, well, that must have been needed to react with the ethanoic acid remaining. So we're going to take off the 2 millilitres, and we were told that 35.0 centimetres cubed were required. So, in fact, 35 minus 2 equals 33 millilitres of NaOH neutralized diethanoic acid, and that equals, well, it's 1 molar, so it's 0.033 moles. Are we up with volume? Sorry, I've jumped ahead. We're only asked for this. I'm going to cut that out. X. Alright, so 33 must have been needed. So the amount of moles in ethanoic acid, well, ethanoic acid moles is equal to sodium hydroxide moles, and we've just worked that out. So NaOH that neutralises the ethanoic acid is 0.033 moles. I say ethanoic acid. Yes, ethanoic acid, that's right. Hence calculate the amount in moles of propan 1-ol ester and water in the final cooled. Well, we've got here alcohol or acid plus alcohol equals ester plus water. What was mixed together? 6 grams of ethanoic acid, 6 grams of propan 1-ol, and that amount of concentrated sulfuric acid. Okay, so, well, let's see. Initial mass from the acid, there was 6 grams of acid. From the alcohol, there was 6 grams, and of course there was nothing from the ester, and there was nothing from the water. Now let's look at initial moles now. Initial moles, well, it's ethanoic acid, which has got a relative mass of 60, so 6 grams is 0.1 of a moles, so that's 0.1. The alcohol, however, is propan 1-ol. Propan 1-ol, let me just, I'm going to just put it in here, propan 1-ol, we need to know the formula, which is C3H7OH. It's propan 1-ol, so our relative mass is 36 and 8, 44. Oh, it's also 60. That's really nice and handy, isn't it? So that's 0.1. Is that right? 60? Just check that. 36, 37, 44, 44 and 16, 60. That's right, so it's 0.1 moles as well. So now moles at equilibrium, EQU moles, well, 0.033 moles of ethanoic acid is left. So equilibrium moles, 0.033, which means that as acid reacts with the alcohol in a 1-to-1, this must also be 0.033, and it means that 0.067 have reacted, so it's 0.067 and 0.067 moles. So now we can use the Kc. Kc equals, it's ester and water concentration, ester and water moles. Copy ester concentration. Now, in fact, they're all in the same container, so they're all at the same volume, so we can use moles as concentration. We divide that by the acid and the ester. Sorry, the acid and the alcohol. Did I say acid and ester? Acid concentration alcohol concentration. So Kc equals, well, the ester and the water's 0.067 times 0.067 divided by 0.033 divided by, times 0.033. Well, you can see that 33 goes into 67 twice, so that goes 2, so Kc equals 4. Oh, I've jumped ahead. Calculate the amount of moles in the final cool. In fact, that's what I should have done. We'll take that there. We should have done the Kc value here. That's our Kc calculation. In the final cooled mixture, and this is our mass in the final cooled mixture. Okay, so that's the calculation completed.